Hi, everyone. Can you hear me? Yeah, I guess so. Okay, so my name is Erez. I'm heading the AppSec research in Checkmarks. We're doing products of code review, SAST and IAST. You have my details here. If you have any questions in the end that you did not manage to ask, feel free to contact me. We are here today to speak about Node.js and NPM as an example for problems in open source. As you can see, the name of the lecture is Could a Few Lines of Code F It All Up? So the short answer is yes. Those of you who came to see the answer for this question, this is the answer. There is a slightly more elaborate answer. This is the longer one, definitely yes. So this is it. Thank you. No, I'm kidding. We're all looking all the time at our code and we are worried that something might go wrong. We look at it, we write it carefully, we educate our developers, security awareness, code reviews, security reviews, analyzing code, checking it. But what if the vulnerable line is this one? What kind of check or test will tell you that this line is problematic? This is a line that requires or imports a third party which is an open source in Node. This is not a real name, but this is how it looks. So what happens if this line is vulnerable? Let's talk about open source a bit. Open source estimated to be in between 65 and 90%, it depends on who you're listening to, of commercial applications. Can you hear this? Okay. I think that the recent estimations are closer to 90%. So open source is a big thing. It's very important to look at it. Open source is great. It's nice. You can find things you did not implement. Our culture of hackers say that no line of code should be written more than once. It can be shared. It can be open sourced. It's great. But there are problems. There are pitfalls. Which one of you here is using open source in his products? Anyone? Okay. As I said, closer to 90%. Raise of hands. How many of these people are 100% secure, relaxed, and safe when they build their code with this open source? One. Excellent. So it's great, but let's talk a bit about Node. Node is a leading framework. I'm sure all of you are familiar with it in different degrees. It's the highlight of JavaScript. I think the big jump was because probably client-side developers managed to become full stack developers. It's easy, it's powerful, and also Node has the platform that allows us to use a lot of open source very comfortably. Some issues with Node repositories are very concerning from a security point of view, and we will talk about them in this lecture. How many of you remember the left pad fiasco? It happened about a year ago. Okay, I think about half. Just to recap, there was a guy named Azer Kochulu, I was told he's called. I hope I'm pronouncing it correctly. Fairly anonymous developer that decided to liberate, this is what he said, his words, his Node.js packages following a disagreement he had with the NPM staff. Among his modules was a little module named LeftPad. LeftPad was a package of 11 lines of code. I have a surprise for you. Here it is. You can write it down instead in case it goes down again. very easy code to implement, not very efficient also, but you removed it. Suddenly, when you removed it, it was around March 2016, a lot of messages on forums and other social media, very similar to this, arose. People that their builds are being broken all of the time because of this left pad. This is the errors they got. Let's see it a bit bigger. As you can see, 404, left pad, registry returned 404. Another line below that is left pad is not in the NPM registry. You should bug the author to publish it, or even better, use the name yourself. Anyone can think about a problem here in this architecture? We'll talk about it a bit later also. So left pad apparently was used by about 40 other NPM modules, other packages, including React and Bubble, used by many developers, companies, commercials, Facebook, Airbnb, and others. The first immediate thing that happened is that Azure is no longer anonymous. Here he is. He's very famous. Also, it actually triggered a very important discussion within the community about these issues. Should an author be able to unpublish his work without a process? There's no answer for that. And what happens to the available module names? No answer for that as well at the moment. So let's talk about the NPM platform a bit. It's the Node.js package manager. It's an open source package manager. The slogan is find, share, and reuse packages of code from hundreds of thousands of developers. Some people sees it as an opportunity. It really scares me, this sentence. There are around 450,000 modules available. I'm pretty sure not all of them are checked for security vulnerabilities. Let's talk about some weak points in the NPM repo. So NPM encourages us to use semver. It's a semantic versioning. For those of you who does not know it, I have an example here. Let's talk about a package called conveniently Node package, version 2.8.1. 2 is the major version, 8 is the minor version, and 1 is a patch. Why it's important, we'll discuss it a bit later. But every time a developer is upgrading his module, he's supposed to bump it up, either the patch or the minor version, if it's a minor version, or the first number if it's a major version. Very simple, very convenient. We'll talk about it in a bit. The main problem with it are that dependencies are not locked to a certain version by default. When you install the first time your package, you download all the dependencies, and by default you are not locked to a specific one. If this package will be updated, if the author will update it, it will be updated when you update the entire package, unless you do something specifically to prevent it. Another problem, NPA utilizes persistent authentication to the NPM server. You log in once, and that's it. Users are not logged out until they voluntarily do so. It's a problem, as you can probably imagine. Other points, centralized registry. If you publish your package to this repository, everyone is taking their packages from this one. If there is a problem with one, obviously everyone is infected. Typing npm publish ships your code to this registry, and it is installed by anyone. Also, during the installation, there are some scripts, hooks that can be could be run, and these scripts sometimes also they can install and even publish other packages by themselves. Let's look at an example. This example is called Active Directory. There is no particular reason I chose this one. I think that during the time I made this presentation, I was working with it. It's called Active Directory, and what it's doing is LDAP client for authorization and authentication. You cannot see, but it has about 20K downloads last month. It's not that much. It's serious, but it's not that much. And it has 4 dependencies. It means that it uses 4 other packages as dependencies to its own code. Okay, so we have 4 dependencies. That's okay. If I want to use it and I want to be definitely sure that everything is okay, my task is to check this package and the 4 dependencies, right? No. Let's see an example of installing it. Okay. This is just a very clear installation of it, clean installation. You can see npm install Active Directory, everything is happening. And then we get to the dependencies. There are way more than 4 here. So what happened? These are the 4 dependencies, but they are not alone. Each one of them has their own dependencies. So while underscore and async have 0 or 1, Banyan has already 4, and LDAP.js has 10. So overall, it has 19 dependencies, this small package. This is a small tree. It could get much larger, obviously. Each one of those can have their own dependencies. And actually, now I see that I was lying because this one and this one are doubled. So it's not 19, it's 80. But still, it's a lot. This is just a small example of how people think that they have, they're covering their dependencies, but then they're surprised to realize that they go much deeper. Let's look at Lodash here. While we were examining a lot of packages, Lodash kept jumping, raising its head all the time. So who is this Lodash? Looking at it, Lodash has about 30 million downloads per month. It has 0 dependencies. On the other hand, it has 45,000 packages depending on it. It doesn't have to be the first level. It could be second and onward levels, like we've seen before. It's recursive. But as you can see, Lodash is something that many packages are very dependent upon. You can imagine what happens if Lodash has a security issue in it. So let's take a look at some potential scenarios. Let's look at ways to cause damage. We can look at the naive way. We can create a useful module. Let's call it WritePad or something nice with hearts and bunnies. That sounds good. Do some good old marketing, actually make it do something, and when everyone is adopting it, update it, and get a backdoor inside all of the packages that use it as a dependency. Another scenario, we can create a module with a similar name. It was actually done a few times. The most famous one is CoffeeScript. Someone tried to create a malicious package. He named it CoffeeScript, but with only one F. Apparently, the real CoffeeScript was downloaded about 20K times a month, and the CoffeeScript with one F was about 3,500. So it was a really big number of people who downloaded the wrong thing just because of the typo attack. Another thing, taking over a legit account. We know that packages are identified by name, so if Azar removes his package, we can go inside and grab it instead of him. Or if I have enough funding and I know that Lodash is so important for everyone, I don't mind even jumping on a plane and go to his house and checking his laptop because it may be worth it. The most interesting thing we saw during the research, while reading other people's work as well, is a self-replicating worm using this architecture. And I would like to go into it a bit because it's very interesting. It's a research that was done by Sam Sakon. I love his TLDRs. It is possible for a single malicious NPM package to spread itself across most of the NPM ecosystem very quickly. This package could enable delivery of a potentially targeted malicious payload to corporate entities. Basically, he's talking here about a breakout of a single worm inside the entire NPM ecosystem. It sounds catastrophic, but it's not that out there. So let's see how we use all the NPM attributes that we talked about before to make this worm. So I talked about lifecycle scripts, the ones that are running when you're doing specific things like installing or publishing or post-install or post-deploy. You can socially engineer an NPM module owner, someone who has a package, to install this infected module you have with a worm. And during the installation scripts, the worm creates a new NPM module. We can see here how the scripts look like. You can see that in the start of the installation, node create this unsuspicious name, malicious NPM module. This one is created. We can see it here. NPM install, Hydra A. This is the name, the actual name here he used. Let's continue. We talked about persistent authentication. This worm is now installed on the computer, which is persistently authenticated. So the worm sets a lifecycle hook on the new module to execute the worm on installation, and then it publishes a new module to the user's NPM account. So if this is John, and he's the owner, the legit owner of two NPM packages, legit1 and legit2, now it's not John that decides what goes up, it's a worm, and it sends its own publication. Here's the malicious NPM module under John. So people who are trusting and following John will have absolutely no problem if they see it, and they will probably download it and use it. Let's upscale. We talked about Semver before, about the semantic versioning. The worm, after installation, traverses through all the user's NPM modules because it has published permissions and access to everything. It adds the new malicious module as a dependency in the package JSON. So each and every package on the server side, on this server, will be infected by this worm. And then the worm publishes new versions to each one of these modules with a version bump. The version bump can be marked as a hotfix. This would be the third number in the version. Hotfixes are usually updated without asking any questions because usually it's meant for hotfixes, bug fixes, security fixes. Unless you deliberately ask not to upgrade to these versions, your next update will do it for you. And this is how it will go through from package to package. Everyone will download it, infect their own packages, and keep publishing for new packages. I talked about a few malicious scenarios. Let's talk about something even more scary than maliciousness, which is carelessness. We sometimes know how to defend ourselves against people who are trying to do things on purpose. It's much harder to mitigate people, developers who are doing things not on purpose. Pop quiz. What's wrong with this picture? Wow. Everyone's too tired. Okay, let me try to narrate it a bit. This function is a middleware. It stands between the server and the user, between the server application and the user. It gets a request, and it wants to strip any null bytes from the URL. It's doing it one by one, replacing one. If there are still null bytes, replacing another one, so on and so forth. It might be an endless loop or a very long one that will create a denial of service. I'll be back to it in a second. So what we wanted to do is to check how many problems we see in the wild in the NPM packages. So we didn't have a real methodology. It was just like we picked what we wanted. So we scanned more than 100 packages, top 50 popular packages, top 50 that are, many packages are dependent upon them, and other popular packages. We mainly wanted middlewares where there is a lot of, let's call it a lot of input from the users. We analyzed the results and then started responsible disclosure, which included contacting devs, waiting for patch, and publishing. All of us here from the IT industry knows that the biggest problem and the biggest point is this one, waiting for a patch. We are still waiting. It's been more than 6 months. Most of them did not yet release patches. So I will not be able to share all the data. I will be able to share some of it. So in the side of NPM, we can see the most popular ones and the most dependent upon packages. This is the analysis we did. You can see here our friend Lodash. The interesting thing to see was the variety in length of these projects. The right column here is the lines of code. You can see that Lodash has more than 128K of lines of code. They are really small packages with 25. We even saw 15, I think. The small ones really didn't have many problems because there is not enough room in there to do many mistakes. Also, it's really easy to find the mistakes when you make them. So most of the problems were in the bigger ones, not Lodash, by the way. So I'm going back here. We got the result of showing us that there is a server denial of service by loop. We checked it. It looks legit. And then we wanted to see what exactly is this package. The package name was node ecstatic. What it did is it enabled the packages that used it the feature of serving static pages, static web pages. Very nice feature. I think that today there are better ways to do it, but it had still a lot of downloads per month and many packages that are dependent on it. This means that each person that downloads this was exposed to this vulnerability, to this denial of service. Each and every one of the packages that used it as a dependency also were exposed, etc. Talked to the developer. The first reaction was no way, really. He said that he doesn't think it will really create a denial of service. So we sent him a POC. What we did is to create a URL, very long one, with null bytes as far as the eye can see, and then just send them to the middleware. The payloads, after 22 kilobytes, we started seeing lags, and we reached the 86 kilobyte payload, the server crashed. So it was confirmed, not only by code, by actual POC. And then we talked to him and he said, oh, okay then, and he fixed it immediately. His fix was to comment the entire thing, just the entire function. We actually thought he's going to just check the length of the URL, But he commented all out. I guess it's a fix. I mean, there was a vulnerability, now there's no vulnerability. I consider it a fix. He also explained somewhere here, it's probably not an issue now or something like that. I don't know. Fixed. Excellent. Other scan results. We've seen command injections where a variable from user input was used as an argument for an OS command, very directly, no sanitization. The developer's response was, the flaw exists because the original author used it. Again, nothing malicious, just careless. And he said a possible solution is to delete the vulnerable file again. I'm not sure why this is the best mitigation, but I guess this is the quickest one. Then we asked him if it's not going to make any problems with the functionality of the package. We never heard from him. And he did not remove the file yet, so we're not sure what to do. We probably will fix it by ourselves and just give him a pull request. Other scan results that we found, command injection, stored XSS, denial of service, a few kinds of them, acute CSV injection, a lot of insecure randomness of people using non-random functions for things that they need to be very random, and even one open redirect. All these results are 6 months old. Before this lecture, I actually asked the research team of Checkmarks to do, in a smaller scale, something very similar. The good news is that it seems like things are looking much better now with newer packages. The bad result is that we did find some issues, and 2 days ago we found an RSE. So still, we're still having problems. So how do we protect ourselves? This is a bit tricky, and everyone should find their own relevant solutions. First of all, you need to inspect the code. Do not install, do not download anything that you don't know what there is. You can go into the registry, you can download a TGZ file and look at the code itself before you actually install it. You need to check if there are any hooks that allow the running of scripts. You can do it by npm show module scripts. You should not allow scripts to execute automatically unless you know exactly what they're doing and what they're affecting. This is done by the flag ignore scripts. You remember the problem with the versions. You can use npm shrink wrap. Shrink wrap makes sure that you cannot use any version other than the version you wanted in the beginning. It's a bit problematic because it really slows down the updating rate. You can also define the exact version you want inside the JSON files, but this is another option. You can lock down the dependencies for a specific version. This is a problematic sentence for me to say because I am very pro open source. But sometimes it is better to run your own functions, especially if it's a left pad with 11 lines of code. And when you analyze your code, either by code reviews, automatic code reviews, tools, whatever, make sure you analyze not only your code, but that you can include all your dependencies inside it. When you install it, make sure you understand this is your code. And any vulnerability in it will be your vulnerability. No one else will find it. And very important, log out of the repository if possible. Other thing a corporate can do is to run a local npm repo and have more control over all these things. That's it. It was a very quick overview of the problems of Node. I think I touched a bit in every subject. I consider it homework. You should go and find and dig deeper to understand all the issues. If there are any questions, I'll be happy to answer. Yes.
So once you found the vulnerabilities in these open source components, do you file CVEs for these? Because CVE is a rather common source for people getting to know about vulnerabilities in open source projects.
Okay, what we do is usually try to, we do have a process of CVEing things. It's very, very slow, painfully slow sometimes. We usually want to fix things before we get numbers of responses. We contact the developers. Most of them usually are very responsive. It takes time for them to fix. We try to help them fix. We sometimes get a CVE a few months later. Sometimes we don't. I don't consider the CVE an important thing in the process, but we do it and publish it.
More questions?
Thanks. Thank you on the dependency in Node. I think this is very good because I've seen a topic about someone sticking a very large bitmap file as a dependency, and it basically screwed up Node for everyone.
Yeah.
But this is actually very good. So, so someone can stick a malicious file, and it will end up everywhere. So you're suggesting to ignore scripts and manually inspect every single package, but it's not a really secure solution. Is there a better solution that you can actually suggest to the Node project and to mitigate this problem in a better way?
Okay, I will try to stay vendor neutral, but you can use like everything in small scale, you can do it manually. When you in large scale, you need to automate the process somehow. So there are automatic tools to do it. For example, in Checkmarks we do it, and this is why I gave the recommendation of when you use an automatic tool to scan a project, make sure you have all the dependencies nested in the right places in the project so you can scan them as well. Anything else?
Maybe one question for me quickly. You say open source tools and bugs and open source tools, but do open source tools use static code analysis for security? What is your experience? Do open source projects use static code analysis?
I cannot really tell you. As far as I know, they use static code analyzers, not the commercial ones, obviously. I'm sure they use them, and I'm sure it helps them. There is a limit of number of lines of code or size. You cannot just, there is no way to do a real code review line by line. So there's no other option.
Okay. So
right at the back. Do you think this is a need that we might need something like the NPM police or something to ensure what's being pushed up is not malicious or there's no vulnerabilities there? And the fact that nothing is there at the moment, this is why we have this sorry state of affairs.
No. I'm trying to add more words to my no. The police will do what we do. If we miss something, they will probably miss something too. It will not replace any of my suggestions anyway. Also, then you will need a centralized body to control it, and centralized bodies have their own rules, which is against the spirit of open sourcing sometimes. I don't know, that's a good question.
So can I just add to that?
Yeah.
So instead of doing it for all packages, it could operate maybe like Docker Hub. So you have kind of the approved ones, which actually give you vulnerability scans, and they're kind of trusted. So it's a bit harder just to push an update to it, but anyone can still add their own things to their own repository. So that might be a good solution.
This is actually a good idea. If someone wants to start it, I'm for it. I don't think it's easy, by the way. It's a great idea. It's a lot of labor doing that. And also who decides if it passed the test or not, who is liable if it's not, many questions.
Do you think there's any value in going the opposite route, really? So rather than having your developers pull directly from the external repositories, maintaining your own internal one that they're pulling from, and if they want something, then you act as the gatekeeper to that?
Yeah, this was one of the suggestions, and mainly in corporate, but obviously you can do it in organizations as well. To have an inside NPM repo, you can whitelist the things you want to enter and even check them one by one. And then the developers can only use these whitelisted packages. This is, if possible, a very good solution for the problem.
More questions? Okay.
Started slow, but then...
So thank you. Erez.